Hi, I'd like to discuss a project called Blinking LED with subroutines. The aim is when the push button is not pressed, the LED flashes every 1 second, and when the push button is pressed, LED flashing half second. The aim is also to calculate the delay with using one machine cycle, and by using delay, use this machine cycle as a exact timing gap. So let's have a look at the code. In assembly code, we have a list of directives with pseudonames equated into the values equated into pseudonames, so the code is a little bit more readable. When we scroll down to reset handler, where we execute setup for the code, so we just enabling bridges in advanced peripheral bus bar for port. We're gonna use these values for linking the port C and port A. Then we're setting up the pin 8 as an output. That's our blue LED. Port C, pin 8, and then pin 0 in port A is set up as input. Stepping down, we're moving zeros into register 1 just to initialize with clean register, and then we loading input data register into register 5. We're masking it with 1, so we are after bit 0. This way we don't care about the rest of the bits in the whole word. And then moving on, we store whatever value we get, 0 or 1, we store it. Then we're testing the register, and if the register if in the register is found 0, we are not branching to half second. We're carrying on in the code, and we then branch off to 1 second delay. So 1 second delay is over here. We're loading the register 4 with the 1 second delay value. This is gonna be calculated. I'll show the calculations, and we go through delay, where we're subtracting 1 from this number. Once is when it's not equal to 0, it keeps looping. Once it's 0, then we carry on in the code, in the subroutine code, and we negate what's in register 1, which is our output, and we store it to output data register. That's where the LED flashes. And then from here we go back to main loop. In the main loop we go around again, and when user presses the button, so the register 5 is number 1 and it's not equal to 0, then we're branching off to half second. In the half second routine, we're loading different value calculated earlier into register 4, and the same manner is tested, is decremented by 1 until is 0. When it's 0, the LED is the state of register 1 is negated and stored in the register 1 again, is put into register 1 and then stored into output data register. That's where we see LED flashing, let's say in half-second manner. Okay, it's just a quick move over here. So in order to calculate exact the value for our register 4, so then it's decremented. So we require a value to be loaded in register in order to get one second. But from that 1 second, to get to 1 second, the main loop and subroutine instructions already take some time, so we minusing from 1 second 2.75 microseconds. This is our remaining time, and this time this time has to be split the way, right? So as a subtraction instruction takes 1 cycle, so this happens x times, and branch, when it's branch taken, takes 2 cycles. So we need to divide our remaining time into 3, so we get value which we can store in register 4. So when we divide our value into 3, the result is 333,333. 0.45 exactly. But when the last time comes around and when the 1 is subtracted from 1, we get 0, and then branch is not taken, then this instruction takes only 1, so we kind of minusing from here, and this is the result. This is our value. Okay, so when we multiply 3 times, we get near 1 second plus the time running all this loop. That's my understanding. And then we have the result value. We divide it with 1 cycle period, and we get machine cycles. How many machine cycles we need. And this machine cycle amount is converted to hexadecimal and loaded to our pseudo address. Okay.